gravitational world.
You're welcome to today's wonderful class. And in today's video lesson, we'll be looking at a very important topic. And I want you to pay close attention to all that we are going to learn today. Our topic for today is description and properties of fields. Description and properties of fields. But by the end of today's lesson, you should be able to understand the concept of fields. Okay, the types of fields, which are gravitational field, electric field, and magnetic field. Also, you should be able to understand the properties of those fields, and also the concept of gravitational field in particular, the acceleration due to gravity, and lastly, the shape and dimensions of the Earth. So these are the things you are supposed to understand by the end of today's class. Okay, let's dive right in. Concept of fields. So what is a field? A field can simply be defined as a region, okay, a region in space whereby a body is influenced by a force, and this force can be magnetic force, it can be electric force, it can be gravitational force. So a region, a field, yeah, is a region in space whereby a body experiences, okay, either magnetic, gravitational, or electrical force. Did you get that? All right. So types of fields. We have three types of field. As I've mentioned earlier, we have the electric field, we have the magnetic field, and we have the gravitational field. A region in space where a body experiences an electrical force is called an electric field. Also, magnetic field is a region in space where a body experiences magnetic force of attraction. And lastly, gravitational field is a region in space where a body experiences the influence of gravity, that's gravitational force of attraction. So these are the three types of fields. All right, properties of fields. Now the first one here is that gravitational field is a vector field. Gravitational field is a vector field. What do I mean by that? It simply means that gravitational field has both magnitude and direction. Now, every object is attracted towards the center of the Earth. That is the second point here. The second property of gravitational field is every object under the influence of the Earth's gravity is attracted towards the center of the Earth. All right. Now, when you leave an object freely to fall under the influence of Earth's gravitational force, that object falls with a value of an acceleration, which we call the acceleration due to gravity. So when an object is falling freely under the influence of Earth's gravitational attraction, it falls with an acceleration, and the value of that acceleration is approximately 9.81 meters per second square. Now, still on that same point, when I leave two objects, okay, to fall freely under gravity, for instance, I have a stone and another bigger stone. Those two objects will fall to the ground at the same time. So that's a property of gravitational field. So when two objects are allowed to fall freely, they fall to the ground at the same time because they are falling with the value of the acceleration due to gravity, and that value is not dependent on the mass of the object. So whether the object is big or small, they fall at the same rate, which simply means that their speed increases at the same rate and they will hit the ground at the same time. Okay, lastly, the last property of gravitational field is that the strength of gravitational field is a proportion, or is a function of the mass of the object. So when we compare the Earth and the moon, the gravitational field of the Earth is more than that of the moon. So if we go to the moon, the force of attraction between the moon and our bodies will be smaller That means that we can move faster on the moon. We can even jump higher on the moon because there is no much force to pull us down as supposed on the Earth's surface. Properties of magnetic fields. Now, a magnet can attract magnetic substances, and these magnetic substances are substances made up of iron, nickel, and cobalt. Iron, nickel, and cobalt, they are called magnetic substances. So every substance made up of these elements can be attracted by a magnet. Now, the next property of magnetic field is this. When you have a piece of bar magnet and you tie a loop or a rope towards the center and suspend it freely in air, or you can just toss it so it can swing freely in air. Now that piece of magnet always and will always come to rest in the north and south direction. So when you suspend a piece of bar magnet at the middle, it always comes to rest in the north and south direction. The north pole usually points towards the north and the south pole points towards the south. So that is a unique property of the magnetic field. Now, the next property of magnetic field is that like poles repel each other, while unlike poles they attract each other. We call that the law of magnetism. Magnetic field is a vector field, just like gravitational field is a vector field. Magnetic field is also a vector field because it has direction. Okay, that's right. Now, lastly is the strength of magnetic field. Now, the strength of magnetic field of any magnetic field is usually strongest at the poles. Now, we are going to look into the concept of gravitational field. Just like I mentioned earlier, or as I stated earlier, the gravitational field is a region in space whereby a body is influenced by a gravitational force of attraction. Okay, for the Earth and objects revolving around the Earth. Remember, any object revolving around the Earth is called a satellite. So satellites that revolve around the Earth, they could do so without spinning off or moving off from their track because of the force of gravity of the Earth with that body. So they could maintain their orbits, right? That's why satellites could maintain their orbits around the Earth. And this Earth's force of gravity or gravitational field tends to pull objects towards its center. So the Earth tends to drag every object towards its center. That's why if we throw something up, the thing comes down. If we jump up, we come down, because the Earth's gravitational field will say, no, we can't go up, come down. But we found a way to overcome this Earth's gravitational attraction. And we discovered that for a body to be able to escape the Earth's gravitational influence, it has to move up with a velocity equal to what we call the escape velocity. And the value of that escape velocity is 11 kilometers per second. So for an object to escape the Earth's gravitational influence, it must be traveling with a speed or velocity not less than 11 kilometers per second. That is what we call the escape velocity. All right. Now, this force of gravity between the Earth and objects around it, between the Earth and the Moon, Earth and other satellites, we call it the force of gravity. And it is represented by a unique formula. And that formula is the gravitational force of attraction between the Earth and another body is equal to the product of the masses of the two objects. That means the product of the mass of the Earth and the product of the mass of the other objects, let me say the Moon, all over the square of their distance apart. And we have a constant there. That constant is called G, and the value of that G is the universal gravitational constant. It's a constant in the universe. Anywhere in the universe, that constant holds. So the force of attraction between the Earth and the Moon will be the product of the two masses of the Earth and the Moon multiplied by the universal gravitational constant G divided by the square of their distance of separation. Okay, this simply means that every two objects that are apart from each other. It mustn't be the earth and the moon. Every two objects that are separated from each other has an attraction. There's a force of attraction between them, but this force of attraction will be so minute. It is so minute that it can be neglected. You get? This force of attraction is so minute that it can be neglected. But once the masses becomes bigger and bigger, just like the mass of the earth and the moon, then this force of gravity or attraction becomes more prevalent. Acceleration due to gravity. So what is this acceleration due to gravity? Acceleration simply means the rate at which the velocity of an object is changing. Okay, that means at any given second the velocity changes from one value to another value. Okay, so it simply means that when you drop an object freely to fall, that object, the speed or the velocity of that object will be increasing by an amount every second. That is what we call the acceleration due to gravity, and that amount is approximately 10 meters per second square. Some textbooks use 9.81 meter per second square. Okay, so it simply means that when I drop an object from a given height and it falls, if it's still falling, every 1 second the speed changes from 0 to 10, another second 20, the next second 30, the next second 40, the next second 50 meters per second. So that is how the speed will be changing at any given second. So if it took 4 seconds for an object to drop to the ground, that means before it started dropping, the speed was 0 or the velocity was 0. So in 1 second, 10, the speed has changed to 10 meters per second. 2 seconds, 20, 3 seconds, 30, 4 seconds, 40. So if an object took 4 seconds to hit to the ground, it simply means that its velocity before it hits the ground is what? 40 meters per second. As simple as that. That is the essence of the acceleration due to gravity. Did you get that? Make sure you're taking notes, because these are very, very important points and explanation. You don't get this kind of thing everywhere, sorry. All right. So still on the concept of the acceleration due to gravity, this simply means that if I drop two objects at the same time, it simply means that their speeds or their velocities will be increasing at the same rate until they hit the ground. Boom. Now you ask me, sir, but when you drop a feather or a piece of paper and a stone, that the stone will hit the ground before the paper? Yes, I agree with you. You have a point there. But there is something you have to take note of. Air resistance. The air resistance for the stone is negligible, but the piece of paper has a large surface area, and it's light. The air, as it's falling through air, the air resistance on the piece of paper or feather is more observed. Okay, it's more prominent. Okay, it's not negligible in this case, so it will affect the rate of falling of that piece of paper or feather. But if both of them are being dropped in a vacuum where there is no air, believe me, both of them will hit to the floor at the same time. The shape of the earth. Okay, the earth is geoid in shape. Geographers say that the earth is geoid in shape. Now, what does that simply mean? It means that the earth is flattened at the poles. The earth is flattened a bit at the poles, then bulges a little as it tends to get to the equator. And the radius of the earth is 6,400 kilometers. That's the approximate value for the radius of the earth. 6,400 kilometers. For now, that's all you need to know about the shape of the earth. And we have come to the end of today's lesson. I hope you enjoyed today's class. Thank you. See you next time. God bless you.